Okay, so 1.6 day 1 is going to be focusing on substitution. So using substitution, so when do we use it is the question here. And we are going to go ahead and use it when one or both equations are solved for a variable or can easily be rearranged. So here's our first example. We're going to do two examples. So example 1, we have the two equations. The first one is y equals 6x minus 11. And then the other one is negative 2x minus 3y equals negative 7. So we're first going to look for an equation that's set up as y equals or x equals. So this one here is already solved for y. And so we're going to take what y equals right there and we're going to plug it into the other equation. We're going to substitute it in to the other equation. So we're now going to have negative 2x minus 3 times this part right here, the 6x minus 11 equals negative 7. And then we're going to simplify it. So we're going to distribute. I'm going to do it in a different color to show the step. So distribute. So now I have negative 2x. And the negative 3 times 6x would give us negative 18x. And then negative 3 times our minus 11 would give us a positive 33 equals negative 7. And then we just keep simplifying. So combined our x's. So now we have negative 20x plus 33 equals negative 7. Subtract the 33 on both sides. And so now we have negative 20x equals negative 40. And then divide by 20, negative 20. So now we have x equals a positive 2. So if we remember from graphing, our final answer should have a coordinate point. So our final answer would be a coordinate point, and we know that the x is 2, but now we need the y. So we're going to take this and plug into one of our original equations. So I'm going to go ahead and plug into the top one. So we have this one here, and we're going to plug it in here. So instead of our x, because we know x is 2, we're going to plug in 2. So then 6 times 2 is 12 minus 11 would give us 1. And so then we just write that there. And then this is our final answer for this example. So then I have one more example that we're going to look at. So I'm going to move it on up here. So example 2. And our two equations are negative 7x minus 2y equals negative 13. And then I have x minus 2y equals 11. So again, I'm first looking for the one that's set up as x equals or y equals first. In this case, neither one are. However, this one can be rewritten. So we're going to rewrite it by adding the 2y on both sides. And when we do that, we're going to have x equals 2y plus 11. So now I have what x is, and I'm going to plug it into this equation where x is. So again, I have -7, and then I'm plugging that in here, 2y plus 11. So I'm going to get rid of that out of the way so that we can kind of see we're plugging that in here. Minus 2y equals -13. And then I'm going to simplify it and solve it for our variable. In this case, we're solving for y first. So I'm going to distribute that -7. So we have -14y minus 77, and then subtract our 2y equals -13. And then we're just going to keep simplifying. So we have like terms. So we have -14y minus 2 would give us -16y. And then we still have the minus 77, and then equals -13. Add 77. So then -16y equals our 64. And then we divide by -16. And we get y equals -4. And just a reminder, this is only half of our answer because we need a coordinate point and we only know that y is -4. So we need to plug this in to one of our equations to get an answer. So you can plug it into any of these. You can plug it into this one here, or this one here. I'm going to go ahead and plug it into the one that's already solved for x, since that's what I'm looking for. So x equals 2 times my y, which was -4, plus 11. So then we get -8 plus 11, which gives us our 3. Again, we could have plugged it into any of these. So I could have plugged it into this one as well. So we could have done x minus 2 times our y, which is -4 plus 11. Oops, sorry, equals 11, since we're doing this one here. So we would get x plus 8 equals 11. And then we would subtract 8. And we would still get x equals 3. So either way would have worked. And that is it for substitution. Check back later for elimination.